Viewers at home, you are welcome to my presentation on linear programming. If this is your first time of coming across my channel, please click on the red subscribe button, and beside it you will see a notification bell icon. Please go ahead to click it so that you'll be notified whenever I drop a new lectures. If you are a returning subscriber, I say thank you and God bless you. Linear programming. Linear programming is an extension of the optimal product mix decision. If you have watched my lectures on limiting factor, I've told you that covers single limiting factor. Single limiting factor. So linear programming is an extension of that single limiting factor which I have covered. It is used where two or more organization resources are limited in supply. You know that limiting factor, that single limiting factor, I told you that the constraint will be one, but in this case you'll be having two or more constraints. You'll be having two or more constraints. That is where two or more organization resources are limited in supply. Where the organization are faced with two or more limiting factors. That is when linear programming will be used. So, what is linear programming? Linear programming is a mathematical modeling approach used specifically to allocate the limited resources of an organization among the various competing product lines in order to achieve the economic objective of the organization under a multiple constraint situation. Under a multiple constraint situation. It's a mathematical modeling approach used specifically to allocate the limited resources of an organization among the various competing product lines in order to achieve the economic objective of the organization under a multiple constraint situation. That is linear programming. It's a method used to allocate the limited resources. You know, I've told you that the organization are facing with two or more constraints, two or more limiting factors. When the organization are facing two or more limiting factors, that means the resources are limited in supplies. The resources to use in productions are limited. And despite the limitations, they want to make a judicious allocation of that limited resources among their products so as to maximize their returns. So that is linear programming. So I've told you that. So the objective to achieve under linear programming could be either to maximize, then objective could be maximization or minimization. Maximization objectives could be to maximize, that is maximization objective, maximization objective. So you usually maximize contribution. Maximize contribution. So where profit is given, profit will be assumed to be the contribution. You know your contribution margin, contribution margin equal to selling price less variable cost per unit. Selling price less variable cost per unit will give us the contribution margin. Your objective should be either to maximize the contribution or to minimize cost. Minimize cost. Maximize contribution or to minimize cost. These are possible objectives you aim to achieve under linear programming. So we want to look at the conditions for linear programming. Under what conditions will the linear programming be certified? Or what are the conditions that the linear programming will be used? Or the condition for constructing the linear programming problem? Conditions for linear programming. Conditions for linear programming. Number one, there must be an objective to achieve. Number one, there must be objective to achieve. I've told you that your objective could be to maximize or to minimize. There must be objective to achieve. In every linear programming problem, there must be an objective. So meaning that you must have an objective function. Number two, resources must be limited in supply. There must be limitations. Limitations, meaning that the resources must be limited. So 2 or more limitations must be involved before you can make use of linear programming. The second condition is limitations. There must be limitations. And the third condition is that the variables in problem must be interrelated. Interrelationship of the variable. Interrelationship. Or interrelated variables. Interrelated variables. The variables in the problems must be interrelated. And number 4, the variable must be linear. The variables must be linear variables. These are the conditions for using linear programming. Number 1 condition is that there must be an objective to achieve. This is usually to maximize or to minimize. Your objective is usually to maximize or to minimize. We usually maximize contribution and we minimize cost. So you must have an objective. The second one is that the resources must be limited in supply. That is, there must be limitations. Number 3 is that the variables in problem must be interrelated. Interrelated variables. Number 4, the variable must be linear in relationship. It must be linear. There must be linear variables. Those are the conditions for using linear programming. So I want to consider an assumptions of linear programming. Assumptions of linear programming. Assumptions of linear programming. Number 1 is linearity. Linearity. So a linear relationship must exist. A linear relationship must exist between the objective to achieve and the factors of production. A linear relationship must exist between the objective to achieve and the factors of production. That is linearity. Number 2 is certainty. 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 Information relating to the various factors of production must be known with certainty. Information relating to the various factors of production must be known with certainty. That is certainty. Number 3, divisibility. Divisibility. Divisibility means the product can be manufactured in part. That is, you should be able to manufacture the product in fraction. So you should be able to manufacture it in fraction or in part. That is divisibility. Where you did not have enough resources to manufacture the whole unit of the product, then you should be able to manufacture it in part. Number 4 is non-negativity. 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 It is not possible to manufacture a negative unit of the product. Have you seen where -2 shares were produced before? So you can't manufacture negative unit of a product. Have you seen -2 breasts? -5 beds? So it is not possible. So you can't manufacture a negative unit of a product. So everything, all the variables must be positive. Everything must be positive. Number 5 is single objective. Single objective. Single mean one. Single objective. By single objective, we mean objective must be single in nature. That is, you should always have only one objective in a given problem. There will be only one objective. You may either have maximization objective or minimization objective, and not both. You may have either maximization objective or minimization objective, and not both. That is only one objective in a problem. That is single objective. Now, I want to consider the steps for formulating linear programming problem. So, formulation of linear programming. Formulation of linear programming. So, what are the steps you need to formulate? What are the steps you need to take in formulating a linear programming problem? Number one step is to define the variables. Define the variables. That is step one. Define the variables. E.g., let x represent a biro, or let me say x represent biros, or the unit of biros. Let x represent biros, and y to represent pencil. So when you put such a statement, the variables have been defined. The step one is to define the variables. Step two is to define and formulate the objective. Define and formulate the objective. Let me just say formulate the objective. Define and formulate the objective. So your objective, you can say maximize your contribution equals to, let's say, 5x plus 7y. Or you put minimize. I've told you that you only have single objective, not both. You can't have both at a time in a problem. So you have minimize cost equals to 3x plus 5y. So that is objective. You formulate the objective. That is the objective function. So the third step is to formulate the constraint. Formulate the constraint. You can have the constraint as to the materials. E.g., you have materials. You have 2x plus 3y less than equals to 1,000. This could be a constraint. And you may have the constraint as to the labor. Where labor is the constraint, you may have 3x plus 4y greater than equals to 2,000. This could be your constraint. You formulate the constraints. Constraints, I've told you that they are the limiting factors. Those factors that are limited in supply. Those factors that are not, those items that are not adequate. Those factors that could hinder the level of production of the organization. So they are the constraint. So you identify the constraint and you formulate that constraint. So you may have materials, you may have labor and others as the constraint in the given problem. Step 4. Identify the non-negativity. Identify the non-negativity. Non-negativity. I've told you that it is not possible to manufacture a negative product. So for it not to be negative, the variables involved must be greater than or equal to 0, or y greater than equal to 0, or you can put it as x and y must be greater than or equal to 0. So for it not to be negative, all the variables involved must be greater than or equal to 0. Step 5. Solve the problem. Solve the problems or the problem. So you want to solve. You may solve it using graphical method. You may solve it using simultaneous equation method. You may solve it using the simplex method. So before I consider the solution to linear programming, or before I consider the methods of solving linear programming, so I want to give an example on the formulation of linear programming. Formulation of linear programming. Example. So you are given this as a question. So you were told the following information is in respect of 3 products. The following information is in respect of 3 products, A, B, and C, manufactured by a company. You are given A, you are given B, you are given C. Then you are given per unit. Then you have the selling price. The selling price is given, and 75 naira for A, 60 naira for B, and 80 naira for C. Then you have cost. You are given the cost information. Then you have direct materials, 24, 27, and 36 for A, B, and C respectively. Then you have direct labor of 15, 20, and 30 for A, B, and C respectively. Then you have fixed overhead, which is given to be 160% of labor cost. If you calculate 160% of 15, it will give us 24. 160% of labor cost, that is fixed overhead. 24, 32, and 48 for A, B, and C respectively. Then you were told that all workers are paid at the rate of 2 naira 50 kobo per hour. All products use the type of raw material which costs 3 naira per kg. During this year, the company can procure a maximum of 12,000 kg of raw materials only. That is the maximum they can procure. That means materials is one of the limitations. If they can get more than 12,000 kg, then they will wish to obtain more materials. So that means material is one of the limitations. And has facility to employ only 8,000 labor hours. They can only employ 8,000 labor hours. Meaning that if they have more facilities, they will wish to employ more labor hours. The company wants to introduce a linear programming technique to ensure judicious allocation of the limited resources. To ensure judicious allocation of the limited resources required. Make necessary calculations and formulate the linear programming objective function and constraint to maximize the company's contribution margin. So the first thing I've told you, the first step is to define the variables. So you have been given A, B, and C as the variables. So now the variables involved are A, B, and C. So no specific product is involved. So now that you are given A, B, and C, and you are given the selling price and the cost structure of the firm, the first thing is you want to establish the objective function. But before you can establish the objective function, you look at the information given. Since you are given the selling price and the cost structure or cost information, then that means you'll be able to calculate your contribution. Remember, I've told you that contribution is selling price less variable cost. So if you subtract variable cost from the selling price, then you get the contribution. Then the contribution, your objective now, the probable objective now could be to maximize the contribution. So now we want to now determine the contribution margin for the company. So contribution margin. So contribution margin. So we have for products A, B, and C. A, B, and C. So we want to determine the contribution margin for A, B, and C. I've told you that contribution is selling price. Selling price. And what is the selling price of A, B, of the products? For A, the selling price is 75 naira, and 60 for B, and 80 for C. So we have 75, 60, and 80. So 75, 60, and 80. From that selling price, we less the variable cost. Let's identify the variable cost. The variable cost in the questions include direct materials and direct labor. Fixed overheads is not variable. So the only variable costs are direct materials and direct labor. So now we want to less the variable cost. Direct materials now is one of the variable costs. So now let's have direct materials. Direct materials. Then we have direct materials. Then we have 24, 27, and 36. 24, 27, and 36. Then we also have direct labor as the other variable cost. So direct labor. Direct labor, we have 15, 20, and 30. 15, 20, and 30. So we have direct labor 15, 20, and 30. These are the variable costs. When you deduct the variable cost from the selling price, you arrive at the contribution margin. Contribution margin. Contribution margin. For A, you have 75 minus 24 minus 15. Then we have 36 naira as the contribution margin from product A. For B, we have 60 minus 27 minus 20, and that will give us 13. And for C, you have 80 minus 36 minus 30. Then we have 14. Then, having calculated our contribution, then I've told you that you are going to establish the objective function. Objective function. Now, your objective now, you want to maximize the contribution. And the contribution, we have contribution. You want to maximize the contribution, which is 36 from A. Now, we have 36 of A plus 13 of B 13 of B plus 14 of C. 14 of C. So that is the objective function. After the objective function, the next step is to formulate the constraints. Our constraint, to formulate your constraint, you put subject to. Subject to. Now you go back to the question. You have put subject to the constraint. Now, when we're reading the question, we've identified two possible constraints of the organizations. All workers are paid at the rate of 2 naira 50 kobo per hour. That is the rate per hour. All products use the type of raw material which costs 3 naira per kg. That is the price per kg. During this year, the company can procure a maximum of 12,000 kg of raw materials. So the maximum raw material they can procure is 12,000 kg. That means one of the limiting factor is material. Now to formulate that constraint, now you have the materials as the constraint. Now you were given the materials in kg, 12,000 kg of materials, 12,000 kg, and this is in kg. But if you go through the table above, the materials is given in naira. This one are in naira, so that is material. Then the kg and naira doesn't correlate. Therefore, you will need to convert the material in naira to kg. To convert, since you were given the price per kg of material to be 3 naira, you were told all the products use the type of raw material which cost 3 naira. So meaning that it costs 3 naira per kg. 3 naira per kg. Since the material costs 3 naira per kg, therefore, how many kg will have been used before these 24 naira were incurred in A? So that means you divide this by 3. That means it will give us 8 kg. 24 divided by 3 will give us 8 kg. 27 divided by 3 will give us 9 kg. And 36 divided by 3 will give us 12 kg. So now, the constraint as to the materials. I've told you, for A you have 24 naira divided by 3, and that gives us 8 kg. For B, we have 27 naira divided by 3, and we have 9 kg. And for C, we have 36 naira divided by 3, and then we have 12 kg. Now, let's formulate the constraint as to the material. For A, 8 of A, plus for B, 9 of B, plus C, 12 of C. Now, and you were told the maximum materials available that the company can procure a maximum of 12,000 kg. Maximum. You cannot have above 12,000. So that is why, since it is maximum of 12,000 they can procure, you cannot have greater than 12,000. You can't have more than 12,000. So you use less than or equal to 12,000 kg. That is for materials. Less than, because you cannot have greater than, the maximum is 12,000. It cannot exceed 12,000. That is why we use less than or equal to 12,000. Or equal to 12,000 means you can have exactly 12,000. You can have less than 12,000, but you cannot have above 12,000. That is the meaning of maximum of 12,000 kg. Please take note of that. Then the second constraint we have identified is labor. Labor is the second constraint. Now let's go back to the question. You were told all workers are paid at the rate of 2 naira 50 kobo per hour. And you were also told if workers are paid 250 kobo per hour, and you were told that the company has facility to employ only 8,000 labor hours. Only 8,000. That is what the company can employ. They cannot employ above 8,000 hours. You know, this is in hours. I've told you that the variables to use must correlate. Since this is in hour, then this too must be in hours. This must be in hours. And what you are given here is in naira, not hours. Then that means you will need to convert the 15 naira and 20 naira and 30 naira to hours so that they can correlate. So for A now, let's convert it to hours. For A, you have A, which is you are given 15 naira for direct labor, and the company pays 2 naira 50 kobo per direct labor hour at the rate of 2 naira 50 kobo per hour. So you have 15 divided by 2.5. That will give us the number of direct labor hours required. So we have 15 divided by 2.5. Then we have 6 hours. 6 hours. For B, we have 20 naira divided by 2.5, and that gives us, you have 20 divided by 2.5. Then we have 8 hours. And for C, we have C, which is 30 divided by 2.5, and that gives us, we have 30 divided by 2.5, then we have 12 hours. Now, remember, the company has facility to employ and has facilities to employ only 8,000 hours. That is the maximum hours the company can employ based on their facilities. So we have for A, remember the labor hours for A is 6 hours. So we have 6 of A plus, for B, the company we have 8 hours. 8 of B, and for C we have 12 hours, and then we have 12 of C. 12 of C. So since they can only employ maximum of 8 hours, that means the correct inequality symbol to use is less than or equal to 8,000. They cannot employ more than 8,000 hours. So since they cannot have above 8,000, you cannot use greater than or equals to. You can't use greater than or equal to when they cannot employ more than 8,000 hours. So the inequality symbol to you is less than or equals to. So now, then the next thing is non-negativity. These are your constraints. Then the next thing should be non-negativity. Non-negativity. I've told you that you cannot manufacture a negative unit of a product. So you must have A greater than or equal to 0, or B greater than or equal to 0, and C greater than or equal to 0. That is for non-negativity. All the products you must have greater than or equal to 0, even whether it is minimization or maximization. The inequality under non-negativity, you will only have greater than or equal to 0. You can never have less than or equal to 0 in either case. So that is formulation of linear programming. Please, that is all about formulation. Then my next lecture shall cover the solution to linear programming using the various methods, the graphical method, the simultaneous equation method, and the simplex method. That shall be covered in the next part. Please, if this is your first time of coming across my channel, so please click on the red subscribe button, and besides it you will see the notification bell icon. Please go ahead to click it so that you'll be notified each time I drop a new video. Thanks.